Hello, this is Jack Jackson. We're going to be looking at the TI-84 today, and specifically we're going to be looking at the built-in application for doing probability simulations. So turn on your TI-84. In fact, go ahead and get one out and kind of follow along with me. This is a similar application on the TI-83 and some of the other TI calculators. We hit the Apps button here, and we get a choice of several things here. If we use the down arrow a few times, we will get down to the thing we're looking for. I think they're in alphabetical order, so we're getting close. You can actually shortcut, I think, by just typing P at this point, but let's go ahead and find it. There we go. Prob Sim, probability simulator. So we hit enter, and it pulls up this application, probability simulation. Now, there are several basic scenarios that we might want to simulate. And probably the most basic one is tossing coins. We can also roll dice, picking marbles from an urn, different colored marbles, spinning a spinner, or drawing cards from a standard deck, or just generating a random number. So these are different things that we might want to do with our probability experiments, some basic things, and other real-world things can be modeled with one of these, one or more of these examples. So for example, let's start with just tossing a coin. Use these keys up here at the top, the Y equals keys and so forth, these up here, to access the things that you see at the menu at the bottom here. So we're just going to click OK. And we can hit the window key and toss a coin. And it came up tails. Let's toss it again. Okay, so +1 will toss it again. And now we have a heads. So right now at this moment we are 1/2 each. Let's flip again. Okay. Now we have another one. So what we see here are relative frequencies here. The relative sizes of the bars. Unfortunately, it doesn't have a vertical scale, so you can't really tell exactly what these things are, but you can see this. Now, what's nice about this is if you want to, you can flip it a whole bunch at once. So we can flip it 10 times, and it tells you what you came up with. Okay, or we can add another 50 to it by doing the next to last button here. And now we'll do another 50. And we can see what we have there. Or we could clear it out, for example, by hitting the graph button. Do you want to do that or not? Yeah, let's do that. And that erases all our memory. Now let's just do 50. Let's do 100 trials here very quickly. So we've run 50 trials, and let's run 50 more by hitting trace. Okay, so we have 100 trials. In this case, we got close to the same number of tails and heads, but just slightly more tails. If we hit the Y equals to escape, we can actually go here and see some of our data or table. Let's go to the table first and see what it looks like. And so here you can see actually every single toss by using up and down arrow. We can go up and down here and see every single toss what it turned out to be. And we see the cumulative number of heads on the right. So if you look at this, we'll see after 100 tosses we ended up with 47 heads. And of course we can subtract to find that leaves, what, 53 tails. We can go to data and hit trace to give us data, and these are telling us that we have some of this data in these lists, toss, C1, and cum H for our lists. So if we get out of here we can see that. We can go here to see the graph that goes back to that setup here. We can go to, again, table, data. We've already seen that. We can also go to, we can do a few other things here. We can go to toss, and it'll actually toss it once for us. Okay. We can go back to set, and set has some variations we can do. We can flip the coins not one at a time, but we can flip 1, 2, or 3 coins at a time. And we can have it give us frequencies or probabilities, which are really relative frequencies. We can store everything in the table or just the last 50. We can clear the table if we want, and we can update it every 1, every 20, or just at the end. We can even go to this advanced thing and make our coin not fair. So anytime you have something, we'll talk about this later, as a Bernoulli trial that has 2 outcomes, call one a success and one a failure. Say the heads is a success, we call this probability P for the probability of heads. Probability of tails or failure would be Q, which is 1 minus P. And you can change these numbers here. And so we can change the weight by actually changing the numbers here. So we can do a 2 to 1, and that gives us the probabilities there. So basically you're entering in more or less the odds or the relative sizes. So 2 and 6 here, 2 to 6, or that would be the same, of course, as 1 to 3, and that would give you a 75% chance of a heads, 25 for tails. Of course, if we go back with a fair coin, then they're equally likely they'll both be 50%, and so we have those settings. Okay. So that shows you an example of how we can use the coin tosser to simulate some data. Okay, we can also roll dice. So let's take a look at the rolling dice. So this will just roll a single die, and so we see it turned out to be a 6. Okay, let's roll another one. Let's see what we get. And then we can do a 3, and we can just do this one die at a time and have this simulate for us, and we can see this and see what happens with the bars as we just do this over and over again. We can also do a whole bunch of them at once. Say if we do 10 more, so it looks like we're up to about 15, and of course we don't get exactly the same number of bars on each one, but maybe something similar. If we do this, say, for another 50 on top of that, maybe we're up to around 65 or so data points. Yeah, 65 data points, and you can see that. And again, we can go to escape, and similar to the coin problem, we can go to the table, and again, this gives us what we have each time. So this first column, it tells us which roll number we're on. Like 65 was the last roll, we ended up with a 2. This is D1 is what we have there, and this will be the sum. If you have multiple dice thrown, this allows us to throw more than one dice. So more than one dice, so you have a pair of dice or 3 dice, and it will add up the total of the dice, and so that's in this column. Of course, when you only have one die, the total and the actual amount are the same. Let's see here. This tells us our data is in roll D1 in the sum, so we should be able to go down here to stat. Let's see if this will let me out. Okay, stat. List. Okay, we'll come back to that. So we also have some things here. Set. This is your settings. Okay, and so notice you can throw 1, 2, or 3 dice at a time, and you can do a standard 6-sided die, or you can do an 8, 12, 8, 10, 12, or 20-sided die. So sometimes you'll see these kind of dice for some role-playing games or some special things that may have multi-sided dice that are not the standard cubic one. And you can also make your die not fair, just like you can with the coin. This one has them all weighted the same, but you can make the probabilities higher or lower. Of course, the probabilities all have to add up to 1. In this case, you actually just change the weights, which gives you a relative frequency on each side, or gives you a frequency here, if you want, or a weight, and then the probabilities will be fixed out based on that. Will be figured out based on that. Okay, so let's just do one where we do a pair. Let's say we do a pair of standard dice, standard 6-sided dice. So I get on the 2 there, hit enter. Now we should be able to say OK. It's going to clear our memory, that's fine. We'll start over. And so now we can go to a roll. And so it's going to roll a pair of dice. And this one we got a 3, then a 2. Okay, so we got or they're doing this die on top as the D1. So we got a 2 and a 3 for a sum of 5. Okay, let's do it again. Three and a 6 for a sum of 9. Let's go ahead and do another 50 here. Now it's not going to show you all of them with the simulation. So the 1 and 5 was probably our next one, but then it's not going to do all. It will do all the rest. Here is simulations, but not the visual simulation, just the numbers. And of course, you can see what the sums here. Now, if we escape, we should be able to go to our graph, and this shows us what the sum was. Again, if we go to table, it gives us our list. And we should be able in a few minutes to look and see what this data does. This will store this data in lists. So if we get out of this altogether, let's go ahead and do this. Get out completely. Okay, and we should be able to quit this. And let's see if this works. We should be able to go to Stat, Edit, and there's our standard list 1, list 2, and so forth. But if we go over a little further, hopefully this is going to be here. Let's see. No, it's not there. Okay, let's quit for a minute. Okay, let's go over here, and let's go to List. Okay, there's our list right here. So some of these are things that we looked at earlier. So roll, so we should be able to go to, let's go back to list. Let's go back to Stat Edit, and I can show you how to do this. Stat Edit. If we go up here on L6, we can go in and give it one of these lists. So go to the list here, and one thing we can do is go down here, and we could do let's do roll. See if this is going to work for us. So this tells us which row we're on. If we go to list 5, let's say, we can go up and go to list, and let's see, we can put D1, for example. Let's go back up this way. Well, there it is, number 9. And then hit enter. This tells us what we got on dice 1 every time we rolled it. And then I think, let's see if we can, let's go over here to List 4 is probably not the best order to put these in, so we might want to clear that first. Go up to L4 and then go to list, and we can go to sum. And so this is what we got for the sums of the dice. This looks like this data is all from the time when we did it with one die. That data is there. Somehow we can get to it. Okay, so we go back to apps. Let's see if I can go straight to this a little bit faster. Let's see if we can get P. No, that didn't do it. Started something else. Okay, apps. Let me just use the up arrow. Oops, there it is. Right there, probability simulator. Go back here. Now let's take a look at some other things. So we've talked about dice and coins. Another thing that we might do is to pick colored marbles out of a urn. So we don't know what's in the urn right now, so let's just see what happens. We pick one out. There's a marble that's, let's say, labeled with A. A might represent just a letter on there, or a color, or type of thing that we're choosing out of this. Or these could be names in a hat. We could have, Adams, Baker, Campbell, whatever. Okay, and so we can draw that. So we're going to pull out another A, and let's do it again. This time we pulled out a B, and so forth. Again, it will give us a table of how we pick them. It does tell us where those tables, where the data is picked, where we can get to that later in our lists. And we go to settings here again, and it'll show us how many types. So in this case we have 5 types, and they'll just use the letters A, B, C, D, E. If you have 4, it's A, B, C, D, and so forth. So you can have 2, 3, 4, or 5 types, and we can pull them out. But we can also go to advanced here and set the number of marbles. So in this case we have 10 marbles of each type, but we can change the numbers of each type there, and we can draw the marbles out that way based on that setting. And then this last one down here is important, replacement or not. So the question is, if I draw this out, do I put it so let's say I drew out an A the first time. There's actually, the way we have it set up right now, there's 50 marbles, 10 A's, 10 B's, 10 C's, 10 D's, 10 E's. And what if we draw an A out the first time, which I think we did? What about the next time? Do I put the A back in or not? If I put the A back in, shake them up, and then pull it out, I still have a 1 out of 5 chance, 1/5 probability of drawing an A. But if I don't put it back in, I have a little bit less. I only have 9 out of 49 possibilities, so 9/49ths rather than 10/50ths. So it changes the probability at least a little bit, and sometimes a whole bunch, depending on the amounts. So whether you do it with replacement or without replacement is important. That's going to be a big thing for us in general when we're looking at probabilities. Okay. So this gives us a way to pick these, and of course we can have a graph of that as well. Now let's look at another option. Another option is number 4, a spinner. In the case of a spinner, we have a little thing, a spinner that's pinned there at the origin, which is the center of this circle, and we have slices, circular sectors coming out from the center, slices of the pie, if you will, And the probability that the spinner lands in any one of those particular ones is proportional to both the central angle and also proportional to the area of that piece. So we can do the spinner. So there it spins. Let's spin it again. And it ends up on a 2 the first time and a 4 the second time. And again, I can add in a bunch. What's the probability each time on this one? Well, they're all equal, so that should be probability of 1/4 each. So if you did this a whole bunch of times, you'd expect these bars to be about the same height. Maybe not after only this many, but if we did 50 more, now we're getting the sample size up fairly large. Law of large numbers is starting to kick in a little bit, so we start to see these about the same size now. If we do it even bigger, maybe another 50, let's see what happens. There we go. Now these bars are going up and down some. If we did the actual counts, the bars would all be going up. But if we're doing the relative frequencies, which is more corresponds to the, which is the empirical probability, then they're going to go up or down as things are added to different categories. Now, if we go back here to our setup, you can see that you can do a few other things here. And again, we can do frequencies, probabilities. We can have there are 4 sections. And 1 per trial. Okay, but we can go to advanced here, and we have the 4 sections. We can weight them different amounts. So, for example, we wanted that one to be 2, this one to be 1, this one to be 3, and well, we could just do that. We could even let one be 0 if we want. Okay, let's take a look at what happens. And do OK. That's going to clear everything out. Now since we set 4 to be 0, we only have these 3 regions, but they're definitely not the same size. So now we wouldn't expect the bars to all be the same size height, or even close to it. We also have drawing cards, number 5. We can draw a card from a standard deck. We got the Ace of Spades. Draw again. Ace of Hearts. That's interesting. 2 of Spades. 2 of Diamonds. 4 of Diamonds, and so forth. We can also go to this one, and let's see if there were anything we could set on that one. Let me try that again. I didn't see anything. Yeah, there it is. Set up. So we should be able to do this. We can draw from some different decks. A 32 card deck. A standard deck is a 52 card deck. We have 1, 2, or 3 cards. So a standard deck would be 52 size. So we can draw from more than one deck at the, shuffle up more than one deck and get that. And let's see if it gave us the option of, replacing or not replacing a card. And finally, we have one more thing. That's the random number generator. And the random number generator, we can, let's go to the settings first of all. This tells us how many numbers to generate and the range that we can go for. So I think we can actually type in a number here from 6 to 50, for example. Are we allowed to repeat or not? In this case it's no, we're not going to allow to repeat. What if we just wanted 1-digit numbers? let's suppose we were allowed to go from 0 to 9, for example, and then we will no repeats. So if we're allowed with that, this is going to generate that. Okay, I got stuff bigger than. Okay, it went 1 to 40. Why did it not? Let's try that again. 0 to 9. Okay. I think I didn't hit OK a while ago. Now draw it. Should give me stuff between 0 and 9. So that gives me 6 one-digit numbers. Okay, so for example, if we wanted to simulate a lottery, let's go here. We want to simulate a lottery where we pull 6 things numbered 1 through 42 and no repeats. Okay, and we can play the lottery. Boom. Let's see what we get. And this would give you your lottery numbers. So we can simulate this particular kind of lottery. So you can generate some sets of random numbers. You can roll dice, toss coin, pick marbles, spin a spinner, and draw cards. These are lots of good things that we can do to simulate different types of probabilities. And if you think a little bit, you can probably get other real-world situations where you can use one of these physical models here to model some other real-world situation as well. So there's a quick introduction to TI-84 probability simulator software.